Okay, welcome everybody. So we were talking last week about how do you manage your team, and one of the things that's going to happen is you're going to have to communicate in a team. We talked about how you do that through Wiki. It's a slightly more formal form of communication, writing down your status, updating your goals. You can have other communication that's even more informal, just as you're going through. Let's see what's happening here. Okay, there. Just as you're going through the daily work of collaborating. So let's take an example from Ken, Abid, and my team. So let's say that Ken has broken the build, or we think that we've broken the build. He's broken the build. So I send him this email. Okay, so remember, breaking the build means it doesn't compile. So Abid and I come in, we do a pull, and we compile, and it doesn't work. We get some errors. We go, what the heck's going on? So I send this email to Ken. What do you think? Just type in the chat or unmute. What's your thought when I send this email to him? Is it good? Is it bad? Anything that could be
Can
better?
I unmute? Can I just speak?
Yeah, go ahead.
First thing I want to say is this kind of I feel like this email is so professional. Is it just me or would just be kind of unrealistic? I
Is
just
it
be like,
so
oh no, the build
professional?
is broken. But I guess a problem I see with this communication is it's not specific enough. And an issue with that is if the person isn't like it makes the communication if the other person is not like ready on the other side, or maybe he's busy and doesn't have a time to see the message, by the time he replies to ask what is broken, it's like there's just a loss of time. I don't know if I'm making myself clear.
Yeah, no, that makes sense. So you said it's not very detailed. It's not time bound. So, if I really need this, I haven't actually given much detail to Ken about exactly what's going wrong. And I haven't actually said, do I need it right away? Or am I just kind of, maybe this would be a nice thing for you to do? Uh, let's see. Ken's pointing out this is the passive voice. Yeah, the build is broken. It's kind of a weak way to say things. Semicolon seems misplaced. That's interesting. I love semicolons actually, and I love the double dash. So, okay, but I agree. These are points. So good points. So one of your points is this isn't very specific. So we didn't make it very specific. Ken said we use the passive voice, which is even less powerful. Haven't made it clear it's Ken's problem. What we've asked him to do is a bit vague. Can he take a look? And it's not clear, is this very important to me or not? So, but it actually is important to me. I'll give you a little more context. I came in, I wanted to work on this assignment. I need to get it done. I can't make any progress because Ken broke the build. So I didn't really communicate very well. Okay, so I can send this instead. So here's my second try. I really want to convey urgency. Okay, Ken, you broke the build. Avin and I can't work. This is unacceptable. Fix it now, right? So actually, as Daniel has pointed out, that wasn't the passive voice. So that's actually true. We made the build, I guess build is the subject. We just took ourselves out of the discussion. So I guess not the passive voice, but we didn't put ourselves in there. Okay, what do you think of this one? So I see aggressive, it's not appropriate, no please or no thank you. It needs to be in all caps. Yes, this isn't a great idea, right? Ken, what do you think? Is this going to make you fix the build right away?
I'm feeling pretty bad right now, Vaughn. I
Yeah,
think
it might
I'll
not be
have
good for
to.
teamwork. So probably doesn't make you feel very valued as a team member. It's not clear why I'm so angry either. I seem angry. Okay, so what do I think of this? Okay, well, on the plus side, it does convey urgency and ask for a specific action. So I'm saying it's important. I want it right now, and you've got to fix it. I still haven't given any evidence that it's Ken's problem. I've just put an exclamation mark on it and said it's his problem. I have said, why it's important and that it's urgent, but the tone's not good. And email has no context. The person can't see you, so email comes across as actually very cold and more aggressive by default. So you want to be careful. Email actually can be a conflict enhancer. If conflicts are kind of spiraling in email, you want to pick up the phone, have a Zoom meeting. All right. So, but I shouldn't send this. Okay, so here's my next option. Okay, so hi Ken, there are many compilation errors in streets.cpp. The last commit to this file was 8 p.m. last night, so we think it's your code. This is holding Abbott and me up, can't compile. Please take a look as soon as possible and let us know when you can fix this. If it can't be fixed in the next hour, we'll have to revert your changes. Thanks, Vaughn. Okay, what do you guys think? Okay, so Sona says, I wouldn't have the energy to read all that. Justin says it's too nice. I ain't reading all that. It's detailed but long. Okay. Okay, so some people think it's better, but they think maybe it's a bit long. Okay, too long, didn't read. Okay, so I'm gonna put down what I think of this. Ken, what do you think? I mean, these are basically, what do you think of this email? If you got this, would you do it? Is it too long? Would you just not read it? You'd stop at hi Ken and go do something else?
For me, it has specific information. And so it's allowing me to consider that, yeah, this may have been a mistake that I made, and you're being reasonable about the consequences. You're being specific about the consequences, and your tone is pretty kind of reassuring, right? You're not attacking me, you're not making me feel defensive, but you're being direct, so
Yeah.
it's clear and still respectful.
Okay. So I think I think this is a lot better too. So it's specific. We give some evidence that it's Ken's problem. We're not just making stuff up. We do convey that this is important to fix, and this is actually important. We ask for something specific. Okay. Um, Let us know when you can fix it, and we set a time limit. This often happens with teams. I'm being held up. Do I have to just wait for Ken to fix this forever? At what point do I give up? So I'm just going to say we can wait an hour, but after that, we're going to actually have to take your changes out. It's going to make more work for you, but we're giving you warning. Okay. Um, so the question, Abbott and me is correct here, by the way. So people are debating whether we got this correct or not. This is correct grammar. So you can take that offline. So I think it's a lot better. It's respectful and polite, but firm. Seems like Ken thought that was a reasonable tone. We're trying to get him to do what we need. So it's important, how does he read this? Not how I want to write it. It's what does he think when he reads it? Now, various people said it's too long. And I think you've got a point. I personally think that this extra information is useful, but we did, in made to stick terms, bury the lead. We probably should have said, there's a broken build, Ken. Can you fix it? Can you fix it right away? First line tells him what we need. If he immediately goes, oh, wait a sec, I think I did make a mistake, he doesn't really need to read the rest. But the rest is there in case, wait a sec, I don't think I broke the build, or what are you asking me to do? But we should have led with, if this person only reads one sentence, let's make sure that one sentence gets the point across really quickly. Yeah, I see questions, just 1 hour too fast or not. When you break the build, actually, I mean, it depends. This is what your team needs. If you're going to bed, you can just say, fix it tomorrow. When someone breaks the build, it often is really holding you up, and you really want it fixed fast. When I was at Altera, breaking the build was a big deal because you have actually hundreds of software engineers working on it. And we actually kept a list of build breakers and would basically publish it periodically. So there was a bit of public shaming, not super nasty, but basically we were one of the top build breakers over the last quarter. Try to be more careful. And there was in the Toronto site and another person in the San Jose site, there's a person whose only job was to basically make sure the build came out on time in the morning, because Quartz is so big, you actually have to build it on many computers when you do a full rebuild. So that person fixes the easy things. Anything that's broken that he or she can't fix, they go find that engineer and they have to fix it right away. Okay, so anyway, on your team, it's not quite as critical as that, but this actually can be an issue where you really need it done fast. Okay. Okay, so I guess those are examples of not necessarily conflict, but we have a problem with a partner. Okay, and maybe if we've got a good, respectful tone and Ken's very responsive, is not a big problem. It's going to get resolved pretty quickly. Sometimes there are bigger problems. Let's say your partner is not meeting his or her commitments, which often happens in team projects. This course being no exception. So I'm going to put you in breakout rooms, and what I'd like you to do is just quickly discuss what are you going to do in that situation. So let's see. So find the breakout rooms. Okay, so partner has not been meeting his or her commitments, fairly consistently. This is not something that has just happened once or twice. You've had an ongoing pattern of partners not meeting commitments. So what are you going to do? Okay, and I'll send you all to the rooms, and we'll come back in a few minutes. Okay, welcome back, everybody. Let's see if I can get the slides going in full screen again. So what ideas did you come up with? So just either type them in the chat or unmute and say them.
I guess first you discussed it, of course, but if they're repeatedly not meeting their commitments, you can tell them that you're going to bring it, like, as a team, decide to bring this up with the TA and give them heads up. Like, if you can't meet such and such commitments, we're going to have to bring it up with the TA or CI.
And that makes perfect sense. So always a good idea. You should talk to them first. Sounds obvious, but you'd be very surprised how many times in this course, Dr. Tallman or I will get an email from a person saying, Bob has not been doing anything all semester and is driving me nuts. And I need you to kick Bob off my team, or I need you to give me a lot of marks from Bob. And the person hasn't actually ever talked to Bob, right? So you shouldn't start by talking to your management, right? Your TA, your CI, us. You should start by talking to your teammates. And that can be an uncomfortable conversation, but you got to get used to doing that. That's what is expected of you as professionals. When you go into industry, if you basically have a problem on your team and the first instinct is to basically always go to your boss saying you need to resolve this, it's not good, right? Your boss is not your mother or father, who frankly also shouldn't resolve things for you, but they don't want to do that. They're there if the problem persists, but they want to know, what have you done? So you got to talk to them first. So if it's not resolved, you don't paper it over. You do talk to your TA or your CI or both. Okay, so very good idea, but you basically shouldn't be surprising them in front of essentially their boss, the TA or CI. Okay, and let's see, what other ideas?
Can I go ahead?
Yeah, go ahead.
I was gonna say, I think Sona I agree with Sona with her ideas in the chat, which is to ask them why they weren't able to make it, because maybe there's something that's preventing them. Maybe the workload's too high. Maybe we're not planning ahead enough. It's not, you need to appreciate that you don't have all the information.
Yeah, that's a good idea. So part of talking to them is you don't start with, you're not doing what I need and that's terrible. You start by, you ask why. So good idea. They may not know they're not meeting their commitments. Maybe they do know, but ask why, have a discussion, give them a chance to explain. Maybe the commitments aren't clear enough. You thought they were clear, but they aren't. That happens too. So give a person a chance to explain. I also see a really good comment in the chats about write it down, write on Wiki. Okay, you don't write it down to start with, but you talk first and you say, okay, what happened? What are we going to do going forward? And they write down that resolution. And you all kind of go, yeah, okay, that makes sense. We all agree on that. Maybe the commitments weren't clear enough. Maybe the person was overloaded, so they committed to too much. But what happened? What are you going to do next time? It doesn't have to be a really long thing you write down, but it shows you've come up with a plan. You write it down. It's transparency. It's also visible to your CI and TA. Okay, so all good ideas. I see some comments like, you can't sugarcoat the matter, and there is a balance here. So you don't want to basically alienate the person by being really aggressive, but there's also often a tendency of, I just don't want to face this conflict, so I don't really want to talk about it, and I'm just going to let it ride for a month or two, and then when it's driving me nuts because my workload's out of control, then I go and talk to my CI or TA. You don't want to do that. You have to get used to having these conversations. Having them earlier makes them better. Okay, so all good ideas. And let's see if there are any other interesting ones. Talking is important here because you don't know what's going on with the person, and talking, even over Zoom or a phone call, is a better way to resolve conflict than to try to do it all by email. So if everything's going well, you can do a lot of things by email. When it's not going so well, make sure there's some, in this case, virtual contact. Okay, so you guys kind of captured everything I thought of here. So talk about it, usually in person, but Zoom phone is next best. Be factual. This is a case where there's some conflict. It's easy to get emotional. Made to stick is correct that emotions make memories stick. So you will remember the person who drove you crazy. So you're trying to sort this out. And yes, this is actually a case where you want to be really factual because you're not trying to get the person to remember a bunch of hurt feelings. So you're trying to de-escalate the emotion. And it's probably not going to go away after one talk. When there are performance problems, they often are, and sometimes they're teamwork problems. You have to commit to, you're going to talk about it multiple times. Probably not going to go away after one discussion. I mentioned this, write down the outcome on the wiki. Maybe we need less aggressive commitments. Maybe you need to make more clear commitments. Maybe you need to track more. The person may still not meet the commitments, but you've given them a better chance. And as I said, if your TA or CI has to give unequal marks, they want to see you've made an attempt to resolve it. So you're behaving professionally, you're doing the right thing. Okay. So we already talked about that. Don't hide it from your CI or TA, but this is not the first person you should talk to about it. You should be talking to your teammate first. Okay. And that is it for those conflicts. Quick question, you can just type this in the chat. Are the breakout rooms too long, too short, just right? If you got any thoughts on that, just type it in. Okay, so I see the first 3 people thought it was about right. Okay, that's great. Thanks. Okay, so we're going to move on to another topic, which is testing. So your philosophy in testing has to be, if you didn't test it, it doesn't work. So you don't assume I wrote this code so it does what I thought it would do. You assume it doesn't, right? You made a mistake. So you assume all code is broken until you prove otherwise, because that's the better assumption. It's safer. It's also more likely. Code usually does not work the first time. It's also true of hardware. It's true of pretty much everything. Look at what the program does, not what it's supposed to do. So that sounds obvious, but I'll often be talking to students who say, well, I wrote it to do this, but so it does that. It's like, well, no, let's look at what it actually does. It's actually doing this. That's the start of this detective work of why does it do that? You're like a detective or a scientist. You're testing hypotheses about what does the program do? Why does it do that? So you know what you want it to do, but it's not doing that. Then just you have to observe its output and try to figure out why would it do that. Track down hypotheses. Think of every case your program should handle and try to cover them all. So actually, sometimes we'll have students who basically, when their code doesn't work, they'll say, I think the compiler's broken. It is possible the compilers do have bugs, but they're very rare. So given that if you just wrote this code 20 minutes ago, it is vastly more likely that your code is broken than the compiler is broken. So that's the more logical hypothesis. Start with that. Okay, so when do you test? So best practice is to develop tests early. So you develop tests as you're coding, or even better nowadays is to develop them before you code, which is called test-driven development. Okay, so in Agile, we prototype, we test and evaluate, we refine. So we need these tests right away. We need them early. And what this does is the tests become the detailed specification. So I see someone asking, how do you test before you code? Because you actually write the test cases. You write, for this input, this is what the output should be. Okay, so you can actually write the test code before you write the code that does something useful. I'm not really religious about this. I think if you develop the tests at the same time as you're coding, so you write some code, then you write some tests, that's also good. But there are certainly advocates of test-driven development who say, no, write down the inputs and outputs and all the test cases first, and then that is your specification. Okay, the advantage of making the tests early is that they become the detailed specification. And you can execute that specification, not just read it. So basically, instead of writing a lot of long specification documents, so this course before Dr. Tallman and I took it over actually had very long specification documents for the old project. And our documents are shorter, right? They still has a bunch of information there, but basically a bunch of the details have been moved into the tests. The tests basically, we want your functions to do the following and handle these cases, we put them in the tests. So that's a form of documentation, but it's a form of documentation that you can actually run, which makes it easier to see if you meet the specification. Okay, so what kinds of tests? So there are multiple kinds of tests. So what you've probably used the most so far are what are called system or end-to-end tests. And these test your program basically the way an end user would use it. So you send in input and you get final output. And you're testing the whole system. So you definitely want those. There is another kind of test, which we use quite a bit in this course, called unit tests. And unit tests test small pieces of a system. So they can test single classes, single functions. So in Milestone 1, most of our unit tests are testing just one of your functions at a time. Okay, so you want to actually some of both of these. So I'll give you a spoiler. It's not like there's a right or wrong. You want some of each. But let me just type this in the chat or unmute and say it. What are the strengths and weaknesses of each of these kinds of tests? So what's good and bad about each of them? So any thoughts? So system tests will fail if anything is broken, does not tell you what is broken. Yeah, so system tests are hard to debug. They test everything. So when they fail, it's not clear where to start. Something is wrong in your program. Difficult debugging problem, okay? And these ones are much easier to debug. They test a small piece of your functionality, much more obvious if it fails. If the unit test for one of the functions in Milestone 1 fails, you start by looking at that function, okay? Unit tests are more time consuming as multiple can be done. So yeah, unit tests you may need more, more time to write these. That is probably true because each one covers a small amount of your program. You need to write a bunch of them. Yeah, and you need system tests. So this is a negative, right? This is a positive, this is a negative, and this basically catch interface issues. Okay, so in other words, what about when two pieces of code interact? Unit tests may not catch that, right? You tested every class or every function by itself, but what about the way people are using them together? So this can catch those interactions. And you don't want to basically have no system tests because then basically your end users are the first people to test does all your code actually work together to do something useful. Okay, so all good points. Let me erase what I just wrote here. And basically you guys captured what I wrote here. So the system tests test the whole system, no gaps, but they're hard to debug. They also tend to be more fragile. So you want your tests to be automatic. And system tests often test a certain user input produces a certain output. And that can be fragile. You make a change in the program and your test fails. Your program's not broken, it just changed its output a little bit. That's a pain because you have to spend a lot of time updating your tests. Okay, unit tests are basically the exact opposite. They're easier to debug because they only test one thing. They're less fragile because they don't check your user interface, your I/O. They just check what the API or the class does. And the way they do that is they actually connect to it using code, what's called a test fixture. They set it up using other code to talk to it. This makes them less fragile. As your code evolves, your unit tests don't have to be updated as often. But they don't test the whole system, so there can be gaps, things you're going to miss. Okay? Let's see. How do you write unit tests when you have global variables? Well, so we wrote them for this course. You can have setup code. So you can have setup code that sets up the system. In this case, we call your load map function to set up the system. And then we call your APIs that answer questions. So you can have unit tests where you need some state and you have some setup code to get that in place, and then you can test one or more classes, and then you can end. Okay? Okay, so we have these end-to-end or system tests. We have unit tests. This isn't a complete dichotomy. There are tests in the middle called integration tests, and they're usually written as bigger unit tests. So they're written using code that talks to your functions to exercise them. But they don't test just one class or one function. They test bigger functionality. So they're moderately difficult to debug. If they fail, it's less clear what happened, but they're still easier to debug than a system level test. And they test a lot of the interaction between classes. So usually it's worth having some of these as well. And basically they're written as unit tests. They're just bigger unit tests. Okay, you want to have more of these unit tests because they each cover a small amount of code and they're easier to debug, and fewer system tests, but not zero. And the reason, again, to have more of these is, well, they're easier to debug. Something breaks in your program, you look at which unit tests failed first. If you fix them, maybe the system level test now passes too, and you had a much faster debugging experience. Okay, so we want unit tests. So we need to test individual classes or functions. Now, how are we going to do that? So here's my idea. Okay, we're going to carefully choose some user input. So I'm going to, basically in my test, I'm going to type some exact input. I'm going to get my program in exactly the right state. I want to just test this struct or class. And I'm going to get my program in exactly the right state so that this struct or class is going to output something, and I'm going to capture that, and I'm going to check if it's the right value. What do you think of this idea for unit tests? Is this going to work? Yeah, I see some no's. Yeah, this is kind of madness, right? Like I'm trying to get this huge program. I'm going to send input into it so that I hope I get this class into the right state so that I can generate some output that's only a function of that class. And I can't do this. This is kind of crazy, right? So you can't do unit tests like that. Okay, so what do we do instead? So we write new code. We write test code that's going to put this class in the correct state. We're going to send it some input, make some calls to it, and then we're immediately going to check the responses. So this is called a test driver. Okay, so let's take my little point class. It doesn't matter what this does, but I got a little point class with an X and a Y and a times equal operator. I would write code like this. So maybe I write a new file called tester.cpp, and in it I write a function. I call it test point times, and it's just going to call functions in here. Okay, so it's going to construct a point. It's going to call this multiplication assignment operator, and it knows what the answer should be. I made a point with x equals 1, y equals 2. After I multiplied it by 3, I should have a point of x equals 3, y equals 6. If it's not equal to that, I failed. So I'm going to print a message, and I'm going to return 1 to say I had one failure. Okay, I need to have a main function. So I actually have to make a main so that I get a program. And in my main is going to be kind of boring. I'm going to say there are 0 errors, and then I'm going to call this test point time functions that I called, and I'm going to capture how many errors it recorded. So I'm going to add into my error count whatever number is returned from this. Okay, so all of this code and this code, it will never ship to an end user. It is not useful to them. It is just to test this struct point class. Okay, so I've written additional code that forms my unit test. And that means I'm actually going to compile my program now in a couple different ways. So usually I would compile this program. Let's say it consists of mycode.cpp. Okay, so this is actually a useful class, does my point. And there's a main program that does something. Maybe it does geometry, I don't know. And that produces some program that I would actually ship to my end users and they could use. When I want to run these unit tests, I actually build a different program. So I'm going to compile mycode.cpp, this code that I want to test again. But I'm now going to compile this tester.cpp file, this one, and this test main.cpp file, this one, and I'm going to produce a new executable. I'm going to call it test.exe. So I produced a different program that uses some of the same code as my real program that I would ship to users, and its only purpose is I run it and it tells me how many errors there were. So that is what unit tests really are. Extra code that compiles into a different program in order to automatically test some of your real code that will go into your end user program. Okay? Hopefully that is clear. Would there be a header file for tester.cpp? Yeah, I didn't draw that, but I should have a header file called testers.h. Otherwise, I can't really call this. So I haven't drawn all the pieces of code. So I should have a header file too. Okay, so We use this technique in Milestone 1. So I'm going to show you what you're really building, because sometimes students get confused about what program am I running. So if you look at the source code tree for Milestone 1, and you're going to use the same tree for the other milestones, you're just going to keep adding to it. You have a directory called mapper. Underneath mapper is something called libstreetmap, and underneath that is a source file. This is where your main code goes. Okay, so we've given you the file m1.cpp. You can make more files in there. You can make subdirectories, whatever you want. Okay, everything that you put in there will be compiled into what's called a library. So it gets compiled into something called libstreetmap.a. You don't really care what a library is too much. It's basically just a bunch of machine code. It's stuff that can run on a computer. So this is compiled code. This is the main thing you are working on in this course. You are building this library. Now you can build a little more. We can build multiple things using this library. What you usually do in Milestone 1 is you want to test it. You just want to run our unit tests and see if all your functions work. For that, you can run ECU297 exercise. ECU297 exercise has a whole bunch of test code in it. It talks to this library, it tests it, it reports. Okay? If something fails in ECU297 exercise and you want to run the debugger, you can copy the code out of it, and there's instructions in Milestone 1 and in the unit test quick start, and we'll talk about this in the tutorial next week. You can copy that code, and you can, in NetBeans, build something called test libstreetmap. So it builds a program, and that program also is just unit tests that are talking to libstreetmap. So it does the same thing. It does whatever you copied. You copied a bunch of functions from ECU297 exercise, it'll run those tests. You write your own unit tests, it'll run those ones. All that code goes in this /test directory. So you don't have to write anything in there if you don't want to, but if you want to run the debugger on the unit tests we've given you, this is how you'll do it, okay? And as I said, we'll do a walkthrough of this next week in the tutorial. You also can build an actual kind of end user program, and that's called mapper. And that basically uses the code that is in your main directory. For Milestone 1, you are not going to write anything there. I mean, you can if you want, but it is not going to have any impact on whether you pass our unit tests or not. So whatever you write there is just for your own purposes. For the later milestones, you'll write some code there, not much, but a little bit of code so that you actually get a program that your TA can run that has graphics and so on. Sometimes this confuses students, right? So the reason I'm talking about this is they'll say, like, I wrote some test code in main.cpp, but ECU297 exercise isn't using it. This is why. You're actually building different programs. Mapper is the end user executable, and either ECU297 exercise, or if you want to take the code and stick it in your own project, test libstreetmap are just running unit tests, okay? Let's see. Will we always be given test cases for the milestones? Yes, we give you unit tests for all the milestones. You're free to make your own, and if you do, your TA will look kindly upon you and be impressed by you. So show them to your TA, but you don't have to. Okay. Where can we see the code for ECU297 exercise? It's documented in the Milestone 1 handout, so go look in there. And as I said, we'll go through it in the tutorial next week, but I don't have time to do a walkthrough right now. Okay, and you can flip between, if you're in NetBeans, you can flip between what you build by choosing the configuration. These first three are going to build and run the debugger on your mapper. These next three are going to build and run the debugger on test libstreetmap. So that's what those are doing. Okay, so unit test frameworks, if you go back and look at the code I wrote here, it's a bit boring. Okay, there's going to be if I actually have a lot of tests for a lot of classes, there's going to be a lot of repetition. I'm going to write things like this over and over again, error plus equals this and so on. So you can write that, but people have made unit test frameworks in order to make this easier. So there's a lot of repetitive code to create these test drivers. So set up the test, check if the test passed, etc. We're using a unit test framework called Unit Test++. And there's a quick start guide if you want to learn how does this work. And that also describes how to run the debugger on the unit tests. So worth checking that out. What do these unit test frameworks do? There are basically macros and functions in there to make it easier to set up a test, which is called in Unit Test++ test or test fixture. That's basically setup code. Check if the test passed. there are macros and functions called that all start with check to see did you pass. Run all the tests. There's a function called run all tests that just runs every one of these tests and adds up the errors. And then they also, the framework basically automatically generates the messages and collects statistics. So you could write all this without a unit test framework, but you're just going to write more code. It gives you some nice subroutines and macros that you can use. And that's how we wrote this. And that's the common way to do it. Okay, so last thing about testing, be paranoid. Assume anything that can fail will fail. And how many people read this article that was we posted on Piazza, the 737 Max article from the Globe and Mail? So if you read it, type it in. There's a paywall. Yeah, the paywall's annoying. If you basically just open it in another browser, you get another 3 articles. So hopefully some people got past the paywall. Usually this, if you couldn't get past it, I'll post another article after this, which basically has a no paywall, but isn't as good. The paywall is not illegal to go past the paywall. They give you a certain number of this. They give you a certain number of free articles per month, and they record it per browser. So, okay, I guess not many people read it, but I'll tell you the summary of it. So you've probably heard a bit about this, maybe a lot about it. So the 737 Max, the key problem with the plane is this. They put bigger engines on it because they're more efficient, but they don't fit under the wings, right? They'd actually scrape the ground. And they didn't want to design a new plane because a new plane costs many billions of dollars and you have to retrain pilots. So instead, they wanted to retrofit the 737 with bigger engines that are more fuel efficient, and they didn't want to have to retrain pilots. But it's aerodynamically not ideal. Where these engines are, the plane actually wants to rotate, okay? When you turn up the thrust, the nose wants to pitch up. So if they redesigned the plane, they would have put the engines in a different spot, but they don't want to do that. So they built a software system called the MCAS. I think it's the Maneuvering Control Augmentation System. And that system basically, if it sees that the nose is going up, it automatically adjusts some of the control surfaces to drive it back down. So because it's dangerous, if your nose goes up too quickly, you can get an aerodynamic stall where you lose lift, and then the plane can actually lose altitude, and it's difficult to get out of the stall. So they wrote this software. Okay, what did they do wrong? They actually did a lot of things wrong. They had a single point of failure. So this is actually pretty shocking, but they built only one sensor that's talking to the software. So if that sensor incorrectly determines the angle of attack, this actually starts to, the system kicks in. And that actually was the cause of these crashes. It actually was aggressively pushing the nose down, despite the fact that the plane was not rising, okay? So that was their first problem, which is a pretty shocking one. The second thing is the software system was not tested with a broken sensor. So if they had made this design with a single point of failure, but created sufficient testing where they said, well, what if the sensor is broken? They would have found that bad things happened with a broken sensor. And they could have actually made the software essentially less aggressive, that if the reading seemed crazy, it actually shut itself off, etc. And that would have been a second place where they could have increased safety. They also did not train pilots on this or document it sufficiently. It was buried deep in the documentation. But basically, again, this is a failure to be paranoid enough. They assumed the system's working, so it wasn't that important to tell pilots about it, which meant if things went wrong, this did go wrong on some planes where the pilots did figure it out, but on the 2 that crashed, they didn't figure it out. And it wasn't easy to figure out because it wasn't in their training and it wasn't documented very clearly. And there was a cultural failure. Safety was compromised for sales. So these things happened. You'll never know for sure, but clearly there were oversights. But the other thing is they were trying to make a plane more cheaply and that was more fuel efficient. So they didn't want to redesign the whole plane. They also didn't want pilots to have to get retrained because that's expensive. So that's a barrier to sales. So they're making some decisions that are compromising safety for sales. So there are a bunch of issues here. Anyway, I will post another article and make sure we can get to it past the paywall. It's a pretty interesting case study, and this may happen in your career. So it probably, hopefully, won't happen very often. Maybe it'll never happen, but you may be called on to design safety critical systems. And, it's important to be aware that sometimes you got to push back on sales. This happened at least once in my career, not where we crashed a plane, but basically we had a bug in Cordis, and it was introduced by my team, so it was our fault, where we misanalyzed the speed of the chip in rare cases. Didn't happen very often, but it could happen. And then we found no systems failed because of this that we know of, but we found the bug in a new chip. But we'd already shipped the software. But we went, okay, we're fixing it in the new release. And marketing did not want to change it because they did not want to tell customers that you had to reanalyze your design with the new software. This is going to cost them money. They're not going to want to do it, etc. And they said, it's rare. We don't believe it's a real issue. But we could see that in 2% of the designs we tested that we had, it was an issue, and we could mispredict the speed and of the chip, and that could actually result in the chip not working at the advertised speed and the system failing. So I argued with marketing, the head of marketing, about this for quite some time. So it started with my team arguing with their team, and it eventually got escalated to me and to the head of marketing. And I was getting pretty worried about it, because I was explaining to them why we had to fix it, and they just weren't agreeing. And ultimately, I just decided this is a safety issue. There's no way we're shipping it. So I told my team, we're done discussing, we're fixing the software. And I sent an email to the head of marketing saying it would be reckless to ship with a known bug that could cause systems to fail. So we won't do it, or I won't do it. And we're changing the software, and I'm not going to change it back. And that was the end of it. So they gave up, and we didn't change it. But I'm not sure usually I don't like to do that, because that actually is a case where you're using coercion, right? So it's not good for teamwork to just say we're doing it this way. So I preferred not to do that. But in this case, I had to. And the reason I wrote in that email, it wasn't a rude email, but it was not a very gentle email. I used the word reckless on purpose because all of these emails are archived on servers. So if there is ever a lawsuit over this, and I was overruled, or basically I wasn't going to change it. Like, I would literally have quit before I changed it. If they overruled me and my successor changed it, they have an email from the senior director of software saying this is reckless, which is going to look incredibly bad in a lawsuit. So there are actually cases where you want to use strong language in a written communication because you want it on the record. And I mean, a famous case of this is the Space Shuttle Columbia disaster, where there was a memo from an engineer who uses very strong language about how dangerous their solid fuel rocket boosters are. And they did not actually make the changes he recommended. And ultimately the space shuttle was destroyed. And that memo was, recorded in their electronic archives and quite damning evidence because of the fact that he was very direct in his language. So it can actually often, in situations like this, your management doesn't like it, but it does motivate them because you're going on the record of this is not acceptable. Okay. I wouldn't do that all the time. Like, in other words, don't do this of the bathroom is completely reckless because it's not clean enough. Like, that's just going to make you seem like you're just constantly going crazy. But in a safety critical situation, you may have to go on the record, written, strong language. So anyway, so I'm sorry though that most of you couldn't read that. So okay, so testing tools. So because testing is so important, there are tools to help you. First one is the debugger. The debugger is your friend. So print statements are your friend. That's one debugging technique. But you don't only want to use that. You also want to use the debugger. Use it to debug when a test fails. So that's why we had you do Milestone 0, and we're doing a walkthrough next week in the tutorials. It's also very useful to use to verify new code. When I write a bunch of new code, I like to actually bring it up to the debugger and just single step through it to just watch what it does. Make sure it's doing what I expect. I'm not actually debugging a failed test. I just want to see it execute and make sure I coded it correctly. Memory checkers. So we already talked about this in Milestone 0. If your program seg faults, which means it's accessing memory it doesn't own, it's behaving very strangely, you may have an issue where you're going past a vector or an array's end or something else, accessing a bad pointer. Those are really hard to figure out because your program starts behaving really strangely, but there are tools to help. That's where you run debug check or val grind and see if they tell you got a problem. You also have There are tools that you won't use in this course, but are useful to know about, called code coverage tools. So these tools track over all your tests what lines in your program have been tested. Okay, so let's say I wrote this code. So it's a function, and it does different things depending on what input I send into it, right? It might go through, if input is 0, it goes through this path. Otherwise, it goes through this path. And if this was my only unit test, I just called it with the number 8, I will go through this path, but I'll never go through that path. Okay? If I run that through a code coverage tool, which is an automatic tool that just monitors which lines have you gone through all your tests, it will say no, nothing ever reaches this line. So it says you've covered 6 out of 7 lines, but there's one that you never covered. And that tells you go write some more tests for that one. Again, we won't use that, but useful to know about. I was visiting Google a few years ago and had to go to the washroom. And in the washrooms, in the stalls, they have what's called testing on the toilet. Okay, and this is a picture of one of their testing on the toilet sessions. So this is on the inside of a bathroom stall. Basically, a group of engineers at Google decided that as the company grew, their testing philosophy they thought was getting weakened. Some of the new engineers weren't serious enough about testing, didn't know enough about it. And they came up with a clever communication idea. Everyone goes to the washroom at some point in the day, not much to do inside the stall. Every week they put up a new little one-page tutorial on some aspect of testing. And this one is about time-based testing, for example. So it's pretty clever, shows how important it is. Also an interesting project management and communication idea. They figured out a way, how do they reach the whole company? And they decided we can reach them through the washroom. When you want being able to test to be easy, so you don't want to test manually. You want to automate it so that as people change the code, they can do the right thing, which is to do extensive testing very quickly. So in EC297, we model that for you by basically having one command to build. So make, or in NetBeans, you can build. One command to test, one command to submit. So you want your infrastructure to be easy. So behind the scenes, these are actually relatively complicated commands, but from your point of view, they're pretty easy. If you set up a company or a project in the future, this is how you want to do it. Make it really easy to do the right thing and do tests. Google, like most good companies, also makes it easy to build and test, so they have single commands to do this, but they go further. They actually make it really easy to deploy. So to deploy means they can actually take some code that you might have just written a very short time ago. You ran these tests, they're pretty extensive, and you can actually run another command and it gets deployed to the real website. So say their search engine or their ad engine, which are the places where they make most of their money, and it starts getting real users and real traffic. And they split it into A/B tests. So a new idea, they might actually say 2% of the web traffic starts getting sent to this new ad engine, and they'll monitor how many people click on the links and see whether it seems like it's actually finding more interesting ads for people or not. And if it doesn't look good, then the engineer can reverse the change afterwards. One of my friends at Google said, he made a change and he made, I forget the number. I think he said it was $50 million for the company by making a tweak to how their ad engines work. So he felt really good about that. The next week he made a different tweak and just started this A/B testing, and it didn't go so well. By the time he pulled the plug, he cost the company $10 million. But they can do it all very quickly. It's very data driven. It allows them to iterate faster because they can go all the way out to customers really quickly. So this is called continuous deployment. We talked about continuous integration. Try to put your code together, test it together very often with your teammates. Google goes a step further where they do continuous deployment and they can actually push it out to customers very quickly and make changes all the way to the customers very fast. And this requires really good testing. Clearly, you don't want to have code going on to Google search engine that just crashes your searches all the time. It's got to be tested well. I see the question, did he actually cost them that? No, he really cost them those money. So did my friend really cost them $10 million? Yeah, he could see, I guess they have metrics coming back of what are the click-through rates on the A, which is the old code, versus your B, which is your new code. And they're both live. It's just the B code is only getting, say, 2% of the web traffic. You got to monitor it for a while to see what's happening. And by the time he decided, oh, this isn't working so well, yeah, it was $10 million cost. Now, Google makes a lot of money, right? So, they could afford that. Well, it's not an opportunity cost because they really did lose that amount of money from their ad sales. Like if you look at how Google does, how Google's ad engine works, there's a whole bidding process going on. Companies are electronically paying them for serving up certain ads and so on. If people don't click on those ads, if you don't serve up the right ads, they really do make less money. Okay. Okay, so I'm going to end there tonight. I've posted the slides already for good coding style, and I think I'll leave them up. And I'll talk to Dr. Tallman about whether we go over these next week or if these just turn into ones that you look at over on your own. There's a rubric also at the end of this lecture for the softer parts of Milestone 1, the wiki, the coding style, Git, etc. So it's on Quirkus. There's a link at the end of the slides. Take a look at it. It'll give you some guidance of what are we looking for in those softer aspects. And with that, I'm going to end the lecture, a couple minutes over. Sorry about that. And I'll be on the line for questions.
For the exact input and output. So how does it work?
Yeah, the way unit tests work, and what I'd recommend is go through the unit test tutorial because it'll walk through in a little more detail how they work. Basically, the unit test is creating another program, and that program doesn't take any input from the user because it doesn't want it.
Yeah.
All it does is it basically invokes certain classes, gets them all set up, and then it makes some function calls to those classes. And it already knows what the answer should be because the person who wrote the unit test knew the answer and wrote those in. So when it gets the answers back from those method invocations or function invocations, it checks each of them against the expected answer. And if they don't match, then it basically prints an error message and it increments an error counter.
Oh, yes.
Does that make sense?
So,
and it can check various things. It can check, is it an exact match? Is it a match within 1% tolerance? It can also check time. So it can get the answer and not just check is the answer correct, but say I should have gotten this answer back in less than half a second. Did it come back in less than half a second? We use all of those techniques in ECE 297 exercise. Some things want a perfect match. Some things it just has to be within 1% or 0.1%, depending on the thing. And sometimes the performance tests are checking, did you come back with an answer fast enough? And you can do all those things with a unit test framework.
Sure. Thanks, Joseph.
Does that make sense?
Yeah.
Do you remember what's the time limit for load map?
It's several seconds. You can see it in the unit test code. So the unit test code for ECE 297 exercise, where it is documented in the Milestone 1 handout, so you don't have to memorize this, but it's in /cad2 /ECE 297s /public / I think it's milestones M1 /tests. Okay, so if you look around in that directory, you'll find the unit tests, and it's visible in there. You'll see a time limit that's right inside the unit test. It's
Also,
several seconds. And it's different for different maps. For really big maps like Tokyo, we make it higher. So it varies from around, for Toronto, it's probably, someone's saying it's 3,000 milliseconds. So 3 seconds for Toronto then. Oh, that's actually for St. Helena. So for Toronto, more than that. In Tokyo, I think we made it several tens of seconds, which is a lot. The reason we give you that long is in Milestone 2, some teams will choose to load the more detailed data, the OSM data. Right now, you're working with the Streets database API data, which is kind of more processed, higher level, faster to load. You also optionally in Milestone 2 can load the called OSM database API, which is more raw OpenStreetMap data. There's some additional stuff in there like subways and bus routes and so on that we didn't kind of organize as much and we didn't bring into the higher level API. There's more data, so it takes longer to load. So because of that, and because you have to process it, we give you a longer timeout for load map than you probably need in case you decide to use some of that data. Does that make sense?
Yep.
If you don't use that OSM data, then you probably are going to find your load map is quite a lot faster than those speed limits. But in case you want to use that data and do some processing, that's cool. We kind of made the limits pretty loose.
Okay, thank you.
Does the exerciser test the performance of load map? Yeah, it does. But as I said, the tests are like pretty loose. The idea is as long as you don't do anything crazy, you have several seconds, and you won't have much trouble passing it. If you put an order n squared loop in your load map, then you're going to fail. And you'll fail generally by a lot. If you do like an order n squared, then your time might go quickly from 2 seconds to like 20 minutes. It may go up a lot. Let's see. I see a question of some teams are being asked to write team charters and some haven't been asked. Is a choice of each CI. Dr. Tolman, are you still on the call? Maybe that's the best one for you to answer. Okay, I'm not sure if Ken is still. It looks like Ken's not on the call. Yeah, that'll be up to your CI to ask. So different CIs may do different things there. I think most CIs are going to ask you to write a team charter, but that's best addressed to your CI. Let's see. Do we care about compiler warnings? Yeah, we do. If you go look at the rubric for code style and project management and use of Git, which, as I said, is in Quarkus under the Milestone 1 assignment now, one of the things your TA is going to look at is, do you have any warnings? And our submission even tells you, do you have warnings? To kind of highlight, you have warnings, you might want to go fix those. You will lose a little bit of style marks if you have warnings. If you have a few, you'll lose a little bit of marks. If you have more, you'll lose a little bit more. Because we want to teach you of get rid of compiler warnings because they're flagging things that are a bit dodgy about your code. You could go look at them and say, oh, I think this warning is safe. The problem is once you have a few warnings, everybody in your team just starts ignoring them. And then when a warning that really is an issue that you should go look at because it's pointing out your code looks funny, and it caught something that you should fix, you don't see it. So best practice is to have no warnings in your code, so we want you to go fix them right away. I see, I guess, Isidore, you're saying you're getting compiler warnings because you added previously undeclared functions. I mean, what I think you're talking about is probably a warning that just says you got a function and you didn't have a header file or a declaration before it. And so you just have to make the declaration for that function. Either stick it at the top of the CPP file or stick it, if you only use that function within the CPP file, or if you can use it across multiple CPP files, put it in a header file and include it. And then the compiler will be happy with you. So it won't take you very long to do that, and it's better style. The operator equals is overloaded for the lat long object. So it will work, and it does check for an exact match. Let's see. I see somebody talking about is load. There's an operation in load map that's n log n. N log n is fine, right? So load map, the time constraint is pretty loose. It's just you really realize how big the difference between order n or n log n is and n squared. If you put an n squared loop in there, you will suddenly see that it becomes unbelievably slow. It's not subtle. Let's see. What is the reference solutions performance on find partial street name? Okay, so there's a question on what is the reference solution. So the teaching team and I have created a reference solution for all the functions you're writing. And what's its performance? It'll be basically 3 times faster than what's in EC297 exercise as your speed limit. So the general way that we set time limits is we take our reference solution and we triple the time, so that if you write a reasonably good implementation, you're going to pass without trouble. Load map, we make it even looser than that. But we don't make them tighter than 3 times our reference solution. Does that make sense? The unit tests have compiler warnings for code and right. Yeah, you don't have to worry about the unit tests. So if you type EC297 submit, you can submit as many times as you want. It'll tell you if it's flagged warnings in your code. So when you do the submit, it shouldn't be building those unit tests that we wrote, and therefore you shouldn't be getting warnings kind of flagged for yours. So that's what I would do. There are some warnings that we can't get rid of easily because they're in libraries that we didn't write. We usually go turn those off so that they aren't polluting you. If there are specific ones in the unit tests that are giving warnings, you could, Isidore, if you file that on Piazza, I'll go take a look at it. Probably I can go get rid of those warnings because that'd be useful. But you won't be penalized for those if they're not in your code. But if they are in your code, get rid of them. Okay, there's a question about find partial street segment. How long should it take? Yeah, 104 seconds is long. So there are much faster solutions than that. So yeah, okay. So